Hello everyone, let's look at Leetcode question 1503, last moment before all ants fall out of a plank. At time of recording, this question has 1.4 thousand upvotes and 387 downvotes. So in this question, we have three input values. N is the input length of the plank. Left is an array for the positions of the ants on the plank at the left side. And right is the position of the ants on the plank on the right side. And we need to figure out the moment when the last ants fall out of the plank, given that each ant moves at a speed of 1 unit per second. So if you look at this first example and pretend it's just one ant for the moment, at position 4, D, it would take 4 seconds for this ant to fall out of the plank. So it's relative to its position. And it gets a little tricky with this sub-problem that says when two ants moving in two different directions meet at some point, they change their directions and continue moving again. Assume changing directions does not take any additional time. Okay, so this is actually not as confusing as it seems. If we take any two ants and they intersect at any 2 points, the result will be that the total length, the total time it takes for each of those ants to fall out of the plank will be the same as if the ants did not intersect. So we'll go more into depth with that concept in a bit, but first let's look at the constraints. So, N, the length of the plank, will be between 1 and 10,000, and the length of left and the length of right will all be between the boundaries of the length of the plank. So there won't be any ants outside of the plank length. And all values of left and right are unique, and each value can appear only in one of the two arrays. Okay, looking at this first example, we first define max time to be 0, and then we loop through every ant position in the left array, and then calculate the max here, and then do the same for the right. So we loop first with t equals 0. So for position ant in left, 4, 3, we have C and D. And we want to find the max between these two. So for ant in position left, the first is 4. And we say what's greater, 4 or 0, because max starts at 0. And clearly 4 is greater. So far max is equal now to 4. And then we loop to the next ant, which is at position 3, and it's not greater than 4, so max time remains as 4. And then we go to, for ant position in right, 0, 1, 0, 1, and we say what's greater, max of max time, or n minus ant position, so we subtract ant position from n, so 4 minus 0 is 4, so max is 4 for A, and max time is 4, so we return 4. And this makes sense if we go through every single second of the ants. First we start with both ants on each end of the plank, and then when 1 second passes by, ants B and C are intersected, so they change positions. And then on time equals 2, ant at C is back at location 3, and ant at B is back at location 1. And then ants A and D are now intersecting, and then these two change direction. So then on the next second, you see that the ants are now at the two ends because they're returning back to their positions. And then finally at time 4, you see the last two ants on the plank, and this means that they're ready to fall off, so we return 4. Now for this second example, we just have all ants in the right side of the plank, so 0 to 7 with a plank length of 7. So we first then loop for ant positions in left, that's nothing, so max time remains 0. For ant positions in right, max time is equal to the max between 0 or n, 7, minus ant position 0. 7 minus 0 is 7. So looking at this first ant, it would make sense that the time it would take is 7 to fall off the plank. And then we can loop through then the remaining ants, and it'll be always 1 smaller than the previous. So max time between 7 or position 7 minus 1, that's 6 to fall off. 5, 4, 3, 2, 1, 0. So clearly the ant on the leftmost position, or the ant of the first in the right array, will take the longest time to fall off the plank, so we return 7. Okay, so here we have the solution. Let's check it. Great, so it works. What is the time complexity of this solution? So the time complexity is O of n, where n is the total number of ants. This is because we iterate through both the left and the right ant positions just once, and this takes O(n) time. The space complexity is O of 1 because we use a constant amount of extra space to store the maximum time. That's it for this video. Thank you for watching.